Okay guys, in this video we'll talk a little bit about trigonometric identities. Now, I'm not going to go through the proof of these, but these can be proven. All you need to do is make sure you learn them. So you learn that sine square theta or x or whatever it is, but sine square of an angle plus cos square of the same angle is equal to 1. Tan of an angle is equal to sine over cos of the same angle. You need to make sure you learn these, and I mean learn them. And once you've learned them, also learn what happens to them when you rearrange them. So for example, from this one we can get that sine square theta is 1 minus cos square theta, and we got that by moving the cos square over there. It becomes minus, so it becomes 1 minus cos square. So this came directly from rearranging that, and by the same token we can get that cos square theta is 1 minus sine square theta, and so on. Just the same way, we can mess around with this and do lovely things like, oh, I don't know, tan square theta is the same as sine square theta over cos square theta, and so on. We can also rearrange it to say that tan square theta times cos square theta is sine square theta, and so on. So we can really play with this and see some great things happen. You make that times properly, and just by doing that you can also see that, hang on a minute, sine square theta isn't that 1 minus cos square theta, so I can say that this is equal to 1 minus cos square theta. All of those great things that you can do with it. But those are just the identities, and the main thing is you just need to learn these two. Once you learn these two, how you rearrange it and use it to your advantage, that is up to you. But let's start looking at some problems, what kind of questions could be asked and how you answer those questions. So our first problem is usually asked like this: prove that, this is our first problem we're going to do, 1 over tan x plus tan x is identically equal to 1 over sine x cos x. Okay, so they want you to prove that all of this equals to that. Okay, now I'm going to go through it the way I pretty much like doing it. I will tell the examiner what I'm doing, so I will say consider the left hand side, so he knows, or he or she knows, I'm working from the left to try and get the right. So I'm going to say that that's going to be 1 over tan x plus tan x. Okay, remember, you're trying to make this turn into that. So always keep an eye on this side here to see what you're aiming for. Now when I look on this side, all I see is that we've got sine x and cos x. There are no tans over here, which means that all my tans that I've got over here I need to get rid of, and that's the strategy I use. So on this side, I'll remember one of our identities says that tan x is sine over cos, so probably put that over here, and I'm going to say tan x is sine x over cos x. So now that I know that, I'm going to replace my tan x with sine x over cos x. So I'll get 1 over sine x over cos x plus sine x over cos x. Okay, now my next job, well, if I got 1 over a fraction, that is the same as the reciprocal of that fraction. So this is the same as cos x over sine x plus sine x over cos x. Okay, so once I have that 1 over it is the same as the fraction reciprocated. Now it looks like we're getting somewhere. I'm going to take the rest of my working out up here now. When I look down at the bottom here, I've got two fractions that are adding. Okay, now I'll find my lowest common multiple, as you know we normally do with fractions, and the lowest common multiple of sine x and cos x will obviously be sine x cos x. So that's going to be sine x cos x. Okay, and I'm just going to take a shortcut here. You already know that what you will end up doing to make this fraction equivalent to what you got there, you have to multiply the bottom by cos x to end up getting sine x cos x. So you multiply the top by cos x as well, and cos x times cos x is cos square x, plus you'll have to do the same here. To make this denominator be a pair underneath here, I need to multiply this by sine x, but you can't just multiply the bottom, you multiply the top by sine x as well, and sine x times sine x will be sine square x. Well, hang on a minute. The top of this is cos x plus sine x, well, cos square x plus sine square x, which we already know is 1. Because we know from the very beginning, the very first identity I've shown you is sine square x plus cos square x is equal to 1. So that means that this whole top is equal to 1, which is going to be then 1 over sine x cos x, which is identically equal to the right-hand side, and we are done. Or you can say as required or something like that, but we've got it now and we're finished. Okay, and that's basically it. The only thing that I'm slightly worried about is if you understood what I did from here to this point. I'm just going to run through it just quickly again, yeah? So your lowest common multiple, you multiply these two, sine x times cos x, you get sine x cos x. And then you do, another way I sometimes get students to think about it is like, if I divided this by sine x, I will be left with cos x because the two sine x's will cancel out. And then you take your cos x and you multiply it by your numerator. And that's where the cos square x come from, because cos x times cos x is cos square x. Just the same way, if I take this and I divide it by that cos x, the cos x's will cancel out, leaving you with sine x. You take your sine x, you multiply it by the numerator, sine x times sine x is sine square x. Okay, so just bear that in mind. Okay, so then, let's now have a look at a different problem. Okay, in our new problem, we need to prove that sine x minus sine x cos square x is identically equal to sine cube x. Okay, so again, the first thing you want to do is to keep in mind exactly what you've got and how you want to deal with it. Well, this is a lot simpler than you might think it is. It all depends. If you decide to go and start mucking around with that, you might end up in trouble. Try to look ahead in the problem before you solve it. Try to see, well, okay, if I do this, what would happen? Would I get into more trouble? Would this actually take me to anywhere that's sensible? What I'm going to do first of all is, well, I'll consider that I've got sine x and sine x there, so I'm going to factorize that out. So if I take the sine x out, then in brackets I'll have 1 minus cos square x. Okay, I'm sorry, I didn't actually say consider the left-hand side because I'm just conscious of time, I'm just going to go for it. But when you do it in your exam, make sure you tell the examiner that you are starting from the left hand side. Some people start from the right hand side and go back, but I like starting from the left and go forward to try and get the right hand side. So tell the examiner you're starting from the left hand side, all right? Okay, good. So anyway, I factorized. I've taken the sine x out. So sine x times 1 gives me back my sine x, and sine x times cos square x gives me that back. But hang on a minute. 1 minus cos square x, we know what this is. That came from here. Because sine x, what I shown you on the first slide at the very beginning, sine square x is 1 minus cos square x if the cos square x goes over there. So I'm going to say, well, I know that sine square x is 1 minus cos square x. So that means I can now replace this with sine square x. So now I'll have sine x multiplied by sine square x. And what do you know? That equals to sine cube x, which is exactly equal to my right hand side, and I'm done. So that was short, sweet, and to the point, provided that you did it in a sensible way. Someone I know is going to go and probably try and expand that first into, I don't know, 1 minus sine square x, and then they'll get themselves into a whole heap of stuff. So I thought that that was pretty much the quickest way of doing it. Let's move on. Okay, so just looking at this one, I know this one is going to take some doing, and we might need to use some dirty tricks. Okay, that's okay, because dirty tricks are allowed with things like these. It all just shows your ability to do maths. So let's consider the left hand side. Okay, so we're working from the left going to the right, where we've got tan square x on top of tan square x plus 1. And we're trying to get sine square x as our answer. Now, the fact that I've got sine square x as my answer means that I need to get rid of all these tans, okay? So what I'll do is I'm going to separate it slightly and say that this is the same as tan square x multiplied by 1 over tan square x plus 1. Okay, all I've done is remove this from the top, bring it outside, so that is equal to tan square x times that. Now I know that tan x is sine over cos, so tan square will be sine square over cos square. Okay, when you square tan, you'll have to square the sine and the cos as well. So that's going to be then sine square x over cos square x multiplied by 1 on top of sine square x over cos square x plus 1. So you might be thinking to yourself, oh, got myself into quite a lot of trouble here now, because bearing in mind I need to get sine square on top there. This is where I'm going to start employing some dirty tricks. I can see here that it's just that I'm looking for. So I want my sine squares, I want the cos squares to go. I can't think of how that might happen just yet. And now I've ended up with a fraction underneath a fraction. You know, it's a bit mad. But look at this 1. What can I think up that's going to save my skin at the moment? That's going to allow everything to be merged so I can do whatever I want with it. Well, this is where dirty trick number 1 is going to come. I'm going to replace this 1 by something else that is equivalent to 1. And the thing I'm going to replace it with would be, let's get rid of that, would be cos square x on top of cos square x. Now don't you even dare think that I've done an illegal thing. I didn't, because this is still equal to 1. Because if I've divided the same thing by itself, it's 1. And why did I think of that? Well, I've got a cos square x there, which means they're going to have a common denominator. And look at what's going to happen at the top there. It looks fantastic already. Okay, or as one of my students would say, it's beautiful, sir, it's beautiful. So let's go. So this bit here will stay the same. So I'll still have sine square x over cos square x multiplied by 1 over, let's sort this business out down here. Denominator is the same, so it's still going to be cos square x on top of, and you just add the numerator, sine square x plus cos square x. Sine square x plus cos square x. I know what you're thinking now, because you must have spotted by now that this is equal to 1. So if you spotted that already, well done you. So this becomes sine square x over cos square x multiplied by, I'm going to do a double whammy here and just finish this off straight away, okay? This becomes 1 over cos square x. And if I have 1 over a fraction, it reciprocates that fraction. So that 1 over cos square x, I probably should put this down here in green. This becomes 1 over cos square x. Just this bit here is 1 over cos square x. And then I have 1 on top of that. So that flips up and turn into just cos square x. Look at the beautiful thing that just happened. This and this cancels each other out. Goodbye, goodbye. And what am I left with? Sine square x. So my final answer then is sine square x, which is identically equal to my right hand side. Well, that was a bit of a challenge, that one, wasn't it? But you have to think outside the box for it. Let's have one last one before we end the video. Okay, so in this one, we're trying to prove that 1 minus sine x over cos x will be identically equal to cos x over 1 plus sine x. All right, so we're going to consider the left-hand side. Let's rewrite it. So 1 minus sine x over cos x we got there. And we're trying to get what's over here. Well, open your eyes and have a look. Always keep an eye on what you're trying to prove. Look at the bottom here. They got 1 plus sine x at the bottom, and I got this measly old cos x at the bottom. Well, let's make a presumptuous move. Let's put in an invisible fraction. So I'm going to multiply this by a conjugate of this, or I'll multiply it by a fraction that involves that. So I'll multiply it by 1 over sine x divided by 1. Actually, I should not 1 over sine x, 1 plus sine x divided by 1 plus sine x. And yes, you might think to yourself, yes, he's using dirty underhanded tricks, but it's completely legal. Because why? This is the same thing divided by itself, which equals to 1. And if I multiply this whole fraction by 1, it doesn't change the fraction at all. So it's not really that dirty. It's just sensible. So let's go. Now what I'll do is multiply my fractions out in the normal way I do. Multiply this by that, multiply that by that. Now when I multiply this by that, can you see it's going to be 1 minus sine x and 1 plus sine x? I'm not going to go into how this works out, but you should know that if you have something like that, it will work out as 1 minus sine square x. It's difference of two squares. If you remember from factorization, if you factorize like 1 plus x squared, you get 1 plus x and 1 minus x. So I already know that that's what I'll get. Okay, divided by, don't be too anxious to expand any brackets, okay? Just leave everything the way they are. So I'll multiply cos x into 1 plus sine x. Keep an eye up here. That's what we're looking for. So I've got my 1 plus sine x. I'm happy with that so far. This cos x might be in the way, but have a look here. 1 minus sine square x. Didn't that come from here? If I bring that sine square x over, cos square x is 1 minus sine square x. So this whole top here is cos square x. So let's replace it then. So we're going to have cos square x on top of cos x 1 plus sine x. And then what will happen, a beautiful thing happens here. This cancels into that. So this completely goes. And what's left of this is just cos x. And so we say finally this is cos x over 1 plus sine x, which is identically equal to my right hand side. And this is now done. Alright guys, so I hope that this was an enjoyable video. I hope that you learned something from it. Learn some dirty underhanded tricks. Try to look ahead of the problem. Try to see if you make a turn here, what would that bring you? If you don't make, if you make a different turn, you know, where that would take you. Try to avoid getting into a lot of trouble. Just try and think ahead first before you write. Otherwise, you'll end up with something quite horrible that is, you know, pretty much difficult to bring back to what you're looking for. So the main rules are, you know, keep an eye on the right-hand side as to what you're aiming for. Anything that you have on the left that is not in the right, you might want to get rid of those first. All right, any questions? Let me know.